Software Engineering Radio Episode 4, Scripting Languages. Welcome to this episode of Software Engineering Radio. This time Alexander and Markus will talk about scripting languages. So to get us started, I think, Alex, could you explain what scripting languages are and why they're such a hype today?
Well, what scripting languages are is actually one of the toughest questions, I guess, because it's not that clearly defined. A lot of people think scripting languages does mean it's interpreted, because it was that way in the earlier days of computing. There were the compiler languages and assembler, and on the other hand, there were the interpreted languages, the scripting languages. But that is not true anymore for a long time. I mean, BASIC is interpreted, Java, if you want, is interpreted.
Yeah, to some extent.
Yeah, of course. And the modern scripting languages like Groovy can be compiled too. So that's not the criteria that's true today anymore.
Okay.
If you look at Wikipedia, they say scripting languages are for short and easy tasks. They are they lack features that are necessary for huge projects with a lot of people, like type safety. I guess we can talk a bit on this later on.
Yes.
They have implicit variable declaration, which is not a good criteria anymore. C# in the next version will have implicit variable declaration too. Scripting languages have dynamic type conversion and automatic memory management. So the Wikipedia definition is not bad, but not so good too, because there are a lot of counterexamples for all of this. So I guess the definition is pretty fuzzy right now. My definition of scripting languages is pretty close to the Wikipedia definition. Scripting languages are usually designed to make programming easier. So they are more human-centered, not so much designed to make it easy to be compiled or interpreted by the machine. They are readable. Simplicity is a huge design principle in most scripting languages. You usually need a lot less code to program the same stuff compared to Java or C++ or the other languages. Dynamic type and garbage collection actually are core features of most scripting languages. And another point is scripting languages are often designed for a specific domain.
So would you say that scripting languages are typically domain specific?
Typically, maybe yes. Not all of them.
Right,
because
Ruby
a language like Ruby is pretty, you can use it for anything you want.
Yeah.
But nevertheless, a lot of scripting languages, look at PHP, it has a main focus on web development.
Right.
So yes, they are often domain specific.
Although, just to clarify for our listeners, you shouldn't confuse these domain-specific languages we talk about here, like being domain-specific for web page development. You shouldn't confuse them with DSLs in the sense of model-driven development.
Yeah, for sure not.
Okay.
There's a huge difference.
Just maybe another historic point in the programming language community, there has been a long discussion about writability versus readability. So that means you should be able to write programs quickly, but maybe not be able to read them easily afterwards. For example, if you look at APL, the numeric processing language, which is very concise, but you can never ever read your programs again. That's not the focus of scripting languages, is it?
Yeah, actually, you could argue that Perl has the same problem.
Yes, okay, but that's a very old scripting language.
Yeah.
So the newer ones like Groovy or Python or Ruby don't have these problems.
Yeah.
Okay. You mentioned before scripting languages are simpler to use. So does it mean they're incomplete? I mean, is it hard to do complex things with them, or because they're simple?
No, for sure not. This is the Wikipedia definition. I'm not feeling good about this definition actually, because you can program anything you want with most of the scripting languages. Maybe besides some stuff like system level software or drivers or stuff like that, or embedded software. Most of the other things you can actually do with scripting languages. That they are, or most of them are complete programming languages. And if you look at the examples where they are used, you can see that it's like that. It's not an incomplete language. It's not a toy language or something like that.
Right.
Ruby on Rails which is a framework to do 3-tier web applications with Ruby, which is a scripting language, is a complete system for writing really complex web applications. A lot of the web shops you actually use day by day are written in one or another scripting language. So that's not it's not an incomplete feature set or something like that.
But is there a kind of hotspot? Are there typical kinds of applications that are built with scripting languages, and are there other kinds of applications you wouldn't recommend them for?
Let's first elaborate on what I wouldn't use it for. Actually, I have a little problem seeing really huge projects with 200 people working on it, being done in a scripting language. That's not the hotspot right now. It doesn't mean it will not, because if you look at Ruby, it's conceptual on a level like Smalltalk. So it's all there. Nevertheless, it's not done often, and there are some pitfalls you have to address, like dynamic typing. The typical usages are shell script replacement. That's the classic point. That's where they come from, actually. Stuff like build environments are often done in scripting languages. A lot of web development is done in scripting languages. I would say that more web development is done in scripting languages right now than in the more serious languages like Java or C#. Also, if you look at a Linux distribution, there are tons of small GUI programs written in tcl/tk, so there's a hotspot too for scripting languages.
Is there anything you could say about the team size? I mean, you already mentioned that you wouldn't do a project with 200 people. Is that a problem of the language, or is it a problem of you wouldn't find enough developers for those kinds of languages today?
It's a bit difficult, the finding developers for the languages, because, like I said, PHP is really huge. There are a lot of people out there that do PHP on a daily basis. So there's a huge pool of script developers. Nevertheless, it's not so much used in huge projects, and I wouldn't say professional developers are harder to find for scripting languages, because of course they do professional stuff there. It's hard to say. I don't think it's a problem of finding people, actually. There are some features of scripting languages that make it tough to do huge projects. Same like Smalltalk, you might argue. Dynamic typing is a thing you have to address. You have to do a lot of more unit tests, for example, to address dynamic typing problems that might occur in huge teams. So huge team is a problem, I guess, for most of the scripting languages right now.
Something I'd like to point out is that today, when developing software, for example, if you look at Java, the most important thing actually isn't the language anymore, one could argue. Instead, it's the frameworks.
Yeah.
If somebody has to learn Java today, learning the language is easy, but understanding all this J2EE or JEE stuff, as it's now called, learning all that stuff and being proficient there and using the right patterns and the right idioms, that's really hard.
Yeah, you're right.
On the other hand, I think a good language cannot be compensated with good frameworks, because, for example, if you look at Java as a counterexample for good language, if you want to associate a piece of behavior with a button or with another event, you have to typically write an inner class that implements some kind of interface and then implements some execute operation, all that. So you basically have to implement the command pattern, writing 5 or 6 lines of code just to get your real business logic somewhere.
Yeah.
If you have a scripting languages with code blocks or closures in general, this is usually just a curly brace and a vertical bar and a couple of functional business logic statements. So you can express things much more concisely, and certain features such as closures are really important to build good frameworks. So you cannot really compensate a good language with a huge amount of frameworks.
Yeah, you're so right on this point. If you look at a framework, and it's more like than a framework actually, nevertheless, if you look at Ruby on Rails, I don't think anyone from the Java community would have come up with an idea and a concept like Ruby on Rails. Of course, you can do copies that are close to Ruby on Rails.
Yeah, they're doing those continuation servers right now in Java.
Yeah, exactly. So you can copy the concept and you can get close, but it doesn't feel the same way. So yes, the language has a huge effect on the framework. Another interesting point there is the scripting languages actually do have huge amount of libraries, they call them, for where you can find functionality for nearly anything you want or can think of. So Perl and Python have huge libraries in the back.
Okay, so maybe just to continue that point you made before, that scripting languages are often used for shell script replacement. Why should I do that? I mean, aren't the shell languages good enough? I'm not a Linux guy, a Unix guy, so I don't really know. So why would you do that?
Well, actually, the modern shells are pretty powerful. If you look at Bash or TC shell, they are huge. You can do anything you want with them, but they are not very. It's tough to work with them sometimes. If you want to debug them, that's all not so easy to do. But the main point for the scripting languages actually is they are more platform independent. You can use a Perl script on, or if you do it right, or with the that you want to do it that way, you can use a Perl script on Unix and you can use it on Windows without a problem. So they are more platform independent than normal Bash or TC shell scripts are. The programming concepts usually are more powerful too. You have object orientation, for example, some kinds of functional programming. So there are more high-level programming constructs in there. And therefore, they are a lot easier to program. For example, if you want to do a build script or a build environment for a huge project, that can be pretty complex. So doing this with Bash can be a pain at least. So they have an edge there.
I have even heard of people who say that instead of building your, in the Java world, instead of building your build scripts with Ant, you should use Ruby for that, because that makes things much easier than all those curly braces, these angle brackets and all that stuff.
Yeah, one huge advantage there is you're not stuck with a declarative type, and you have just a declarative type of declaring what you want to build and what are the dependencies. When you do it with Ruby, you can program anything you want in this script. So there's no limit there.
Yeah, that's actually true, because if you want to do like conditionals in Ant and do something only in certain circumstances, that's really a pain. I mean, that's not.
And another point is with scripting languages, you can do more complex or complicated even stuff there too. You have GUI libraries, you can do networking stuff using web services, whatever you need. So you're not limited actually.
The next point is something that maybe everybody thinks about when thinking about scripting languages. Are they slow?
That's complicated too. They don't have to be slow. That's the first point. Actually, there's nothing in the concept that makes them slow. So it's more of implementation problems sometimes, or it's not really a conceptual problem. Nevertheless, right now it's that way that most of the scripting languages are a bit slower than the native compiled languages like C or C++ or so on. So yes, usually they are a bit slower. Of course, this doesn't have to be a problem. Nevertheless, it's a fact.
Usually not a problem that they're a bit slower. If you don't do number crunching, then that usually doesn't matter, because the bottleneck is the network or the database or whatever.
Yeah. And if you look at the design principles of Ruby, the creator of Ruby always said it's more important to make the language easy to use, easy to read, and not performance or faster. That's not the main focus of scripting languages usually. So if they have to make a trade-off there, they usually decide against faster as option.
Yeah, I mean, and that means as a consequence that maybe, as we said before, you wouldn't use the scripting languages to develop embedded automotive software that controls the burning process in your engine, right? So that's not the target or the typical domain.
Yeah, and for the other stuff like web shops or things like that, it's also not a problem actually to use a scripting language, because usually network or database are limiting factors there. So the pure CPU power isn't that important in this domain usually.
Right. Yeah. And of course, I mean, in the end, it's always the same. If you want additional flexibility and reflection and dynamic this and dynamic that, then you pay a price.
Yeah.
It's always the same.
Yeah. Another point there is a lot of scripting languages get ported to standard virtual machines like Java Virtual Machine or .NET runtime. So they use approaches the other languages use too and get performance benefits from that. It's not easy. It's a lot of work there, but it also helps performance a lot.
So how important is it for the popularity of scripting languages that they can be run on mainstream VMs such as the Java VM or the .NET Common Language Runtime?
I think it's a huge point to get them on these platforms. If you have a tight integration with Groovy, for example, and Java, you can do a lot of fancy stuff. You can call Java classes from Groovy. You can write unit tests with Groovy testing Java classes and backwards, of course. So that's a huge point for things you can do with scripting languages besides the performance point.
So does that mean that if we use a scripting language on Java and can reuse all the libraries like J2E and stuff, that still doesn't mean that the frameworks are kind of built with the scripting language in mind. So it really doesn't feel exactly like I don't know, like Ruby on Rails. It's still Java with a little bit of syntactic sugar, right?
Exactly. That's why the Groovy people do develop their own frameworks right now. They do their frameworks with a Groovy spirit in it, parallel to the Java stuff. So you're so right. That's a huge point there.
Okay. Not sure if this is the right way to go either. So we have Java EE and then we have Java Groovy EE. I don't know.
Well, I'm not sure. I guess the better solution will win there. And if we stuck to Java, whatever that means, because I don't think Java is as bad as most people say right now. So nevertheless, if we stuck with Java, we might lose some advantages of the scripting power, and maybe we have at least we have the possibility to combine them and use the best of both sides. So it's about choice, I guess.
Yeah, some people argue that the phase where Java is the motor of the innovation is already kind of gone. I think it wasn't Bruce Eckel who wrote this book Beyond Java, or who was it?
Bruce Tate, I guess.
Bruce Tate, I don't know. I have the book lying around somewhere here. So that kind of shows that some people think that the phase where Java is really the language for the really creative people is over, and that they move to languages like Ruby.
Yes, I think so too. It's pretty obvious if you read the weblogs right now. Most of the people that are very noisy, at least, switch over to Ruby right now from the Java community. But I guess it's also a bit of a Gardner would call it hype cycle thing.
Of course.
Ruby is great, but Java is not that bad either. So you have to use the right tool for the problem you have, I guess.
Yeah. And maybe just to conclude this section about mainstream VMs and scripting languages, Java will provide a better integration for scripting languages in the future. The JSR 223 deals with better integration of scripting languages into Java 6. That will probably be Java 6.
And Groovy is not the only Java scripting language to just mention here. There's Bean Shell, which has been there for I guess years at least 3 years. I don't know, for a long time right now, which is pretty popular. And if you look at Bean Shell, one feature is used that you get from this integration. You can use it as an automation language for your applications. Actually, you can embed Bean Shell in your program to make automation of your program possible.
Okay,
huge feature.
Okay, so if we look at scripting languages from a programming language feature point of view, can we point out a couple of really cool features that many or most scripting languages today have?
Also very, very difficult point because they are pretty different. You have scripting languages that come from a non-OO background and right now are moving to an OO background or getting OO languages. And there are pure object-oriented languages like Ruby, which are really designed to be object-oriented from core on. So scripting languages are, of course, very, very, very different. So everything I right now say, you find counterexamples for anything.
Okay.
Nevertheless, most of them have regular expression embedded in the language. You remember they come from this shell replacement thing and background, and there you have to do a lot of things with strings and so on. So regular expressions and easy string handling, easy handling of data structures like arrays or hash tables are very important things. They are in any scripting language right now. What they also do have is automatic memory management. They have garbage collection built in to make it easier, as said before. So to program, you don't have to deal with all this technical stuff there. You just program in the problem domain. They're usually very open to use other programs, to start other processes, to stop them, communicate with them. So they are usually integrated in the environment or the operating system.
So that's maybe also a consequence of history where scripting languages were often used to glue together building blocks that have been built in other languages.
Yeah. Exactly. Some have a lot of more functional flavor, something like high-order functions as objects or closures. This is also point of the easy-to-program thing. So a lot of advanced features in there, but not so equally spread between them. They have different concepts there. They often have powerful reflective features. To dynamically build programs, you can, as they are usually interpreted, you of course can expand or extend the program by the program itself easily.
So that means you can write code that dynamically builds classes. Like for example, you can ask your user, give me the attributes of your data structure you want to have, and then you build an algorithm that dynamically builds a data structure that has those attributes.
Exactly. Of course, with Java or C# you can do all this too, but it's a lot easier to do it with scripting languages.
Right, because in Java you'd have to do it on bytecode level.
Yeah, exactly.
And that's not very fun.
It's not easy. Yeah.
No. But I think we'll have separate episodes on functional languages and also on reflection, because those are huge topics that we cannot discuss today.
Yeah.
One thing that almost has religious discussions about it is the discussion about strong typing. Yeah. People say, we need strong typing, otherwise the compiler can't tell me, all those kinds of bugs. Yeah. What do you think about that? How important is strong typing? And static typing before runtime?
Well, actually, this is almost a religious topic. You find strong proponents on both sides. I guess it's very complicated topic, and I think we should do another episode on this to go deeper into detail there, because it's not that easy to differentiate between dynamic typing and static typing. There are a lot of points to discuss. My personal opinion is you don't have to have static typing, actually. Static type checking by the compiler is a useful thing and helps a lot. Nevertheless, you can write, you have to pay a price for it. You can't just send them message, call a function, send a message is the more dynamic way of it. Send a message to any object you want, and the object decides if it can handle the message or if it doesn't. So you can do a lot of cool things with dynamic typing, actually. But it comes with a price. You have to do more unit tests. You have to check a lot of things that the compiler checks usually for you in the static typed languages. That's one of the points that makes it really difficult to use scripting languages in huge teams, actually. You have to use discipline instead of, a technical or a language feature.
Mm-hmm. Many people say that if you write the right amount of unit tests, like those, test first folks, they say that if you do that, then you will catch all the typing problems also. So that means if you use Java and you write so many unit tests that you cover all your functional requirements, then this would also catch all the typing problems. So that means that you in languages like Java, you don't have the advantages of dynamic typing, but the advantage of the compiler catching the static typing problems don't really pay off, because you would catch those problems also if you wrote so many unit tests as necessary to test your functional
absolutely
logic.
My opinion. The only problem I have with this is usually people don't write enough unit tests. So
yes,
it's more a theoretical point, I guess. If you would, yes, absolutely. And I think it's the better way, actually, because then you not only have your typing problems fixed, but also your semantic problems fixed.
That's it.
Doing the right amount of unit tests is the real solution. But if I look at the projects I see all over the world right now, they don't have enough unit tests. So having a compiler that helps there additionally is not a bad thing, actually.
Right. Okay.
And
so
one additional point there. If you look at the next version of C#, for example, they move to not really dynamic typing, but you don't have to declare what type of variable you have. The compiler figures it out in the while compiling. So the static typed languages also move a bit more to the dynamic typed languages. Still, there's a huge difference in. Nevertheless, they move in this direction right now.
Yeah, I think C# 3.0 is a really, really good example of how kind of classical languages like C# or Java kind of move into the direction of into a domain where typically dynamic languages have been, like with kind of automatic typing, with language integrated query, with closures and all these things. I actually will try to get some Microsoft person on the podcast to talk about that, because I think that's really fascinating.
Actually, and on the other hand, it's a huge misconception that scripting languages don't have type checking at all. They do type check. All the variables have types. You just handle it in a different way. So
you don't have to declare
at runtime, and it's different.
Yeah.
But as said, this dynamic versus static typing thing is a huge thing. I guess we should really do an other episode on it.
I took a note for that, so we'll do that at some point. Okay, so can you maybe list a number of typically used scripting languages, and maybe point out on a very high level view that they're their most important features?
Yeah, of course. First that comes in mind, of course, is Perl. I think it's still the most used. I'm not sure. I have no statistic, but it feels like that. Perl is grandmother of the modern scripting languages, I guess. Very strong, or at least at the point of time when it was invented, very strong on this regular expression stuff, which also brought it a bad image, because a lot of people wrote Perl code that was ugly and almost impossible to read, which doesn't have to be like that, of course, but a lot of people have mixed feelings on Perl. nevertheless, the most important, I would say, or the hugest scripting language at least still. Python came up to be very clean by design. One interesting point at Python and most discussed, while not so important actually, is they have semantic white spaces, like in the early COBOL versions, where it does matter where you write something, how many spaces are in there. This is a point where a lot of discussion is going on. So
I hate it. I really hate it.
I love a bit about it because it's funny to see this little feature so hot discussed by different people.
Of course, you don't need the curly braces, right?
Yeah.
I once tried to generate Python, and so you have to generate all this semantic white space, and that's really a pain.
Oh yeah, I could imagine that's not easy. Python has a huge library, a lot of stuff you can use out of the library. Next language that comes to mind right now, because it has a lot of noise around, is Ruby. Ruby is a purely, or with a design goal to be purely object-oriented, and it actually is. It's very beautiful implementation of object orientation, in my opinion. Very nice little language. Huge in Japan. Actually, it's the most used scripting language in Japan, where it comes from, I guess, or place two. Very, very popular there. Has a lot of noise generated with the Ruby on Rails framework or solution right now. Very, very nice language. I would recommend to look into it. It's interesting to learn it. All the meta-programming concepts are very, very nice implemented.
That I think when we do the episode on reflection and meta-programming, we'll do this based on Ruby.
Yeah, good idea. Next language that comes to my mind is Groovy. Why Groovy on this list? Because I come from a Java background. I've done a lot of Java things. So Groovy is basically a mixture of the best of features of most scripting languages, has a lot of Ruby flavor, but runs on the virtual machine, which is a huge difference. So still in well, it's not done right now. Still, it's going to grow. It has to stabilize still, but very interesting language and concept too. If you don't need something you use right now in a huge project, look into Groovy. If you are in the Java world, of course.
Right.
So very interesting language too.
So to summarize, Perl is very good in string handling. Python is more or less a functional language with OO concepts added. Ruby is an OO language with some functional concepts added. And the big point of Groovy is certainly its Java integration.
Yeah. And actually Perl is not only good on string handling, of course. It's
okay, right. But that was traditionally used. Yeah. And also many people say that you shouldn't kind of really compare Perl with Python, Ruby, and Groovy, because Python, Ruby, and Groovy are really more modern languages where people looked at how you can cleanly implement functional or object-oriented programming, whereas Perl is more or less a mix of useful features, but not a real nice feel to it.
Yeah. Because, of course, this is a lot of taste comes there. I don't think we can say one is better than the other. Just look at them, and you will see what fits your wishes best.
One topic that we didn't discuss yet, but that's important, is what about IDE support? Yeah. Are there any Eclipse for Ruby?
Yeah, well, actually, this is a weak point of scripting languages, in my opinion. There are plugins for Eclipse for different scripting languages, actually, but they are basically text editors with syntax highlighting. So it's not very strong IDE support for scripting languages right now. This one of the reasons is actually this static versus dynamic typing thing. It's hard for an IDE to figure out what are the types of the variables you deal with, because they simply are not defined at the time you write it. Yeah. They are defined at runtime. So it's pretty hard to write something that can do advanced stuff like refactoring, for example. Actually, you can do, if you look, the origin of refactoring browser was done in Smalltalk.
Yes.
It's different. It's very different. I don't know how deep we should dive into this, how they are implemented. They are pretty different. I mean, if you have a refactoring browser for Java, the IDE actually knows what type it has to deal with and where it will be called or where a method will be called and all this stuff. In the Smalltalk refactoring browser used a different concept. It actually replaced code, and at runtime you come, for example, into a dummy version of the function you call, or the method you call, and this will do refactoring or complete the refactoring at runtime. So it's a very, very different concept.
Okay. So that means today IDE support for today's scripting languages isn't as good as what you know from Java.
Exactly. Yeah.
So that there are IDEs like Active State or Script Solutions for
for
Groovy.
sure.
But if you're used to Java,
yeah, it's different. It feels really, really different. But you can do debugging in your IDE. You have syntax highlighting and all this stuff. But that's almost all of the features you get.
Right. So what should our listeners do if they want to dig deeper? Because our time is already more or less up.
Okay. First thing, of course, is to choose your language. There's a lot of information on the web. I guess we will add a few links to our website where you can check
the show notes,
starting points to get a bit deeper feeling how the languages feel, what are the key features, and what's the philosophy behind them. So I would say you have to choose your favorite language, which is easy, I guess, because they are pretty different languages.
Okay.
And then just use the web pages. There's a lot of information on the web because most of the scripting languages are actually open source languages, some kind of open source. So most of the information actually is on the web. And of course, there are a lot of good books, but start with the web.
We'll put a couple of things into the show notes and you can start from there.
Yeah.
Okay, anything else you want to say about scripting languages that you really want our listeners to know about?
Actually, I think we have touched the most important points in the discussion. So just take a look at them. I think scripting languages will get huge, or are huge actually, if you look at the distribution of languages right now. They become more and more important, and I think we will see a lot of influence of scripting languages in the future on the non-scripting languages as well. So having a good understanding of scripting languages will help you a lot in the next years.
And we promise that we'll bring further episodes down the road on specific topics such as dynamic typing or reflection or these kinds of things. Okay. So, thanks.
Thank you.
This was another episode of Software Engineering Radio. For general information, feedback and past episodes, go to se-radio.net. Software Engineering Radio wants to thank Henning Pauli for providing the music we use in this show.